Hello there, welcome back to trigonometry. Today we're going to dive into the wonderful world of radians. Okay, if you've never heard of radians before, they are another way of speaking about measures of angles. So far we've been using degrees. A circle can be divided up, if you look at one complete rotation through a circle, they can be divided up into 360 units called degrees. So we say the measure of the circle is 360 degrees. Radians give us an alternative measure that ends up being very practical for use if you go higher beyond trig into calculus. Radians make something called a derivative way easier to deal with when you're doing things like derivative of a sine or derivative of a cosine and so forth. You'll notice that radians are used so often in practical applications in science and engineering because they just work out better. They have cleaner answers, better numbers. So we're going to learn what radians are. We're going to learn a little bit about using them. And as you go through your book now, some problems are going to be in terms of degrees and some problems are going to be in terms of radians. So it's going to be especially important to check your calculator's modes. Before with working with degrees, we made sure the calculator was in degree mode. But if you're working in radians, you got to make sure the calculator's in radian mode too. So we got to be careful with that. But before we go, if we get too far ahead of ourselves, let me explain what a radian is. Okay, let's take this circle here that's situated on XY axis system. And the center of the circle is right here at the origin. And let's say we have an angle where the initial side is on the positive x-axis, so this angle's in standard position, and then the terminal side is somewhere else out here. Just put it there. Now that angle intercepts an arc of the circle. Like right along here, you've got this arc of the circle. With angle theta here. Now angle theta, in the past we've been referring to the measure of that angle in degrees, but with radians, a radian is actually a ratio of the length of the arc that's intercepted by that angle compared to the radius of the circle. So with that angle, the vertex of the center of that circle, the radian is the ratio of the intercepted arc length to the radius of the circle. Alright, so usually the intercepted arc length is denoted with the letter S. Usually the radius of the circle is denoted with the letter R. Okay, so when you're figuring out radian measure, a quick formula, since radian measure is the ratio of that intercepted arc length to the circle radius, we can say it's S over R. So theta equals S over R. Okay? So that's in a nutshell what radian measure is. Now if you have, let's see, let me draw a little circle here. And draw some axes real quick. Okay, let's say you have a circle here with radius r. Let me draw an angle real quick too. Alright, let's say you have radius r And let's say the intercepted arc length is the same thing, it's the same length as r there, as the radius. Well, in that particular case, the radian measure would be r over r, or 1. You can write radian or not write radian. If you don't see anything, if you just see that if they just say angle measures 1 and they don't say anything else, then you know it's in radians. Degrees will always have a degree symbol. Radians don't have a symbol. In fact, since a radian is a ratio like this, it's a pure number. So it's not a unit of measure, because S and R are expressed with the same units. The arc length and the radius have the same units. So you don't when you do the ratio, the units basically cancel out and you're left with a pure number. So you really can't say it's not a unit of it's a unit of measure, really. It's a ratio. So like you could say just 1 radian, or you could just say 1 for that, if we're talking about the theta there. But we go ahead and refer to it as radian measure, because even though it's not technically a unit of measure, this is the way we refer to it. Okay. Now, an interesting thing happens, like if you start playing around with these ratios, you can start seeing like what 2 radians are, 3 radians, etc. Like let's say you have a circle where you have that central angle, you have that angle, and let's say that your radius is still r, but let's say that your arc length here, like if you were to take this arc from the circle and stretch it out straight and measure it with a ruler, let's say that it's twice whatever the radius of the circle was. Well, in that case, figuring out the radian measure, it's the ratio of the arc length, the intercepted arc length, to the radius of the circle. So you end up with 2. So 2, you can just leave it blank, or you could say 2 radians. Alright, if you go all the way around the circle, just some fun stuff here. Let me draw the circle first, it's easier. Oops. Let's say you go all the way around the circle. So you got this. But that's not just your initial side, that's also your terminal side. Go around like that. So that's your theta. Well, you've got still radius is r. And this time, your intercepted arc length is the full circumference of the circle. Our circumference is 2 pi r, right? Well, if your intercepted arc length is full circumference, it's 2 pi r. So when you go to look at theta and do the radians, you've got arc length of 2 pi r over radius of the circle r, and that reduces down to 2 pi. So complete circle there, you got 2 pi radians. Or if you have half the circle, then your theta would be pi radians. Because half of 2 pi. And to abbreviate radians, you can say rad, R-A-D. Alright, well that relationship, just looking at what's going on with a full circle, that gives us a really good tool for comparing radians with degrees. When we look at a circle, we know that the circle has 360 degrees. Well, we also now know that a full circle, that if you're looking at the theta here, if the intercepted arc makes a complete circle, the theta can not only be 360 degrees, but it can be considered to be 2 pi radians. So let's say we want to do some converting. Let's say we want to convert from radians to degrees or degrees to radians. Well, if you divide both sides by 2 pi, you get 180 degrees over pi. And that'll convert to radian. Multiply by that to help convert to radians. Convert the radians, sorry, to the degrees. Or if you take that and divide by both sides by 360 degrees, you can use this to convert degrees to radians. Okay, let me show you how that works. Let's say you have an angle that you're told is 108 degrees. And you're told to convert to radians. Well, if it's in degrees, you need the degrees to cancel out. So we're going to make this a fraction. So the conversion factor, we're going to use the pi over 180. Because by having the 180 degrees on the bottom of the conversion factor, the degrees are going to cancel out, because degrees are a unit of measure. They'll cancel out, and that'll leave us with things in terms of pi, so we'll end up with the radians. So you end up with 108 pi over 180. And let's see here, 3 will go evenly, and you get, what, 36 pi over 60. 6 will go evenly, so you get 6 pi over 10. 2 will go evenly, you get 3 pi over 5. So 108 degrees, an angle with that measure is the same size as an angle that's 3 pi over 5 radians. Or if you want to go the other direction, let's say you want to convert radians to degrees. Let's say you have something like 11 pi over 12 radians you want to convert to degrees. Now remember, radians, you don't have to say radians because it's a pure number. So let's convert to degrees. So if you already have 11 pi over 12, what you need to do is multiply by the factor that has the degrees on top, because you're going to end up needing degrees left in there. So multiply 180 by 180 degrees over pi. And the beautiful thing there is that the pi's reduce out. Let's see what else it can reduce. 12 and 180. 12 will go into itself one time, and it'll go into 180 15 times. So you multiply, you got 1 on the bottom. 11 times 15 will give you 165. And that was still degrees. The degrees is there, it didn't cancel out with anything. So your final degree measure is 165 degrees. So you're multiplying by degrees, so you're getting up with degrees in your answer. Whereas up here, you had degrees on top and divided by degrees on the bottom, the degrees canceled out and left you with radians. So that's how you convert back and forth. So it's really handy. You can make sure to convert depending on what your situation is to decide what you need to do. Alright. Now there's some very common angles that we've discussed before where we talked about the common right triangles. We had the right triangle with the 30 degrees, 60 degrees, 90 degrees. We also had the right triangle with the 45 degrees and 90 degrees, 45, 45, 90. Those are some very common angles, so it's good to start, really kind of get familiar with some of the radian measures that go with those. If you take 0 degrees, 0 degrees times your pi over 180, you're just going to get 0 for your radians. 30 degrees times by pi over 180, and you're going to end up with pi over 6 radians. 60 degrees times by pi over 180, you're going to get pi over 3. 90 degrees times by pi over 180, you're going to get pi over 2. 45 degrees times by pi over 180, you're going to get pi over 4. And so on. Then if you start looking at multiples of those, then you'll have multiples of the radians. Like if you take 90 degrees times 2, you get 180 degrees. And if you take pi over 2 times 2, you get pi. 30 degrees is pi over 6. Well, 30 degrees times 2 is 60 degrees. Pi over 6 times 2 is pi over 3. If you look at a circle, you can start to see these pi's. It makes a little more sense. Keeping in mind that all the way around is 2 pi. Well, keep in mind that to here you got pi. That's 180 degrees. When you start looking at fractions of that, halfway to here, that's half of 180. That's 90 degrees. That's half of pi, or pi over 2. Or if you look at a quarter of the way, right here, quarter of the way, that's 45 degrees. So that's a quarter of pi, pi over 4. So if you start looking at these more closely, the radian measure reflects what fraction of pi they are. And then keep going, and that's still like, then you can start thinking about it as like what fraction of 2 pi, and so on. So you have some very common ones. You want to be familiar with some of those common ones. You want to be able to go all the way around the circle. So it's, start looking at, okay, what with the different reference angles like 30, 60, 45, 30, 45, and 60 in quadrant 1, what those radians are. But what is that going to translate to in quadrants 2, 3, and 4? Start looking closely at those, because we're going to pretty soon talk about something called the unit circle. And the unit circle is a circle set up with all those common ratios. And then from the unit circle, we're also going to look at the sine, cosine, tangent, and so forth of those same common angles. But now we're talking about terms of radians versus degrees. So do explore that a little bit. We still have a little more to talk about with radians. I want to do some things on arc length. I want to talk about angle measures, etc. Could do a couple of word problems. But this right here is your introduction to radians. So stay tuned. Come back for some applications to go with this too. Thank you for joining us.